Welcome back to JavaScript Fundamentals. One of the most important things you'll do when writing software is make decisions. Now, I'm not talking about decisions that you yourself make, kind of like, oh, well, I'm going to write it like this. No, I'm talking about adding intelligence to your software. Because we as developers have the ability to add intelligence by making decisions in our code. If a certain criteria happens, then we want to do something. Otherwise, we might want to do something else. So today we are going to look at what's at the heart of a decision, and that's called the condition. It's a statement that returns true or false, and we have a set of operators that we use to write conditional statements. And we'll start with some of the easy ones called comparison operators. Comparison operators compare two values and then return true or false based upon that comparison. So for example, let's create a variable called foo and let's compare 5 and 6. This is a condition. It is comparing the value 5 with the value 6, and the comparison is the less than comparison. This is the less than operator, and it is exactly like the less than sign in normal math. So this condition is going to return true because 5 is less than 6. But if we change the operator to the greater than operator, then this condition is going to return false because 5 is not greater than 6. We also have a greater than or equal to operator. We just add the equal sign after the greater than sign. This would return false because 5 is not greater than or equal to 6. But if we change this to 6, then this condition is going to be true because 6 is greater than or equal to 6. We can also use the less than or equal to operator, and this would return true as well. But if all we want to do is check to see if one value is equal to another value, we use what's called the equality operator, and that is two equal signs, one right after the other. We can't use the single equal sign because that is the assignment operator. So to compare one value to another value, and if you want to check if they are equal, you use the double equal sign, which is the equality operator. There's also the inequality operator to determine if these two values are not equal to one another, and that is the exclamation point followed by the equal sign. And in this case, this condition would return false because 6 is equal to 6. It's not equal. So if we change this value to 5, then this would return true because 5 is not equal to 6. But we also have some quirkiness regarding our equality and inequality operators. For example, let's compare the string 6 with the number 6. This actually returns true because what JavaScript does is it looks at the two operands, which is what we have here. We have one operand, which is a string containing 6. And then we have another operand, which is the number 6. So it looks at the operands, it sees that they are two different types, and then it converts them to the same type and then compares them. Most of the time, we don't want that functionality. We want to make sure that one value is exactly the same as the other value. And so for that, we have what's called the identity operator. It does two things. It checks to make sure that the two values are of the same type, and then it checks if those two values have the same value. And the identity operator is 3 equal signs. So more often than not, whenever you want to compare to see if one value is equal to another value, you want to use this identity operator. So in the case of our condition, this will return false because the two operands are not identical. The string is not a number, therefore it's not even going to check the value. It's going to return false. But we do have the non-identity operator, which is an exclamation point followed by two equal signs. And this will return true because these two values are not identical. We have a string and a number. And it doesn't even have to be two different types of values. If we have a number 6 and a number 7 and we use the non-identity operator, this will return true because they do not have the same value, even though they are of the same type. Now, instead of looking at numbers, let's look at strings. So let's have a string that says hello, and then let's use the identity operator, and then let's have another string that says hello but has a capital H. These two values are different. Even though they have the same word inside of the string, they are two completely different strings because one has a capital H while the other has a lowercase h. But if we do change the uppercase to a lower, then this will return true because these two strings are identical. And really, it's not a case of identity. It's just a case of equality. This code would return true because hello with a lowercase h is the same as hello with a lowercase h. But changing one of these, even though we're not using the identity operator, this would return false because these two strings are completely different because of the uppercase h. So we've talked about case sensitivity before. All of our identifiers for our variables and our functions need to be case sensitive, and the same is true with our strings. If we want strings to be equal to one another, then they need to have the same casing. We have a few other conditional operators that we'll look at in a few minutes. They're called the logical operators. But before we look at those, I want to show you how we make decisions in our code. We do so using an if statement. It uses the if keyword followed by a set of parentheses, and then inside of these parentheses we put our condition. So the idea of the if statement is, if our condition is true, then we want to execute some code. And the code that we want to execute is in between these curly braces. So we have if followed by our condition and then a set of curly braces. And the code that we have inside of the curly braces, it can be one statement or it can be multiple statements. It really doesn't matter. But whatever code we have listed in between of these curly braces is going to execute when this condition is true. So right now the condition will return true because 5 is less than 6. So let's alert 5 is less than 6. And then after the if statement executes, normal code execution begins. So let's put something outside of the if statement. Let's say this is outside of the if statement. So whenever we run this in a page, the if statement will execute first. We will see an alert message that says 5 is less than 6, and then we will see another alert saying that this is outside of the if statement. So let's run this within the browser. 5 is less than 6. This is outside of the if statement. Well, what happens if we want to execute code if this condition is false? Because as it is right now, the code that we have written isn't going to do that. This code is going to execute regardless if this condition is true or false. So, for example, let's switch this sign to a greater than, and then let's run it in the browser again. We're not going to see that alert saying that 5 is less than 6 because the condition is false. So we're just going to see this is outside of the if statement. So the code outside of the if statement will execute regardless if this condition is true or false. But there are times when we want to execute code if the condition is false, and we use the else statement to do that. And it's a lot like the if statement, except we don't have a condition. It's just if a condition is true, then execute this code. If not, then execute whatever we specify on line 6. So let's alert this is in the else block. So let's go back to the browser, refresh, and we'll see this is in the else block, and then we will see this is outside of the if statement. Let's look at another example. Let's assign a value of hello, all lowercase, to foo, and then let's compare this value to other string values. So let's do hello with a capital H, and let's alert hello. And then let's perform similar comparisons. Let's do 2 more, so we have 3. Go ahead and paste those. Let's do this one all lowercase. So this comparison is going to return true. And then let's do one with a capital O. Paste that in. So let's first execute this code and then we'll talk about it. We get hello, in all lowercase, and then we get this is outside of the if statement. So whenever the browser executes this code, it's first going to evaluate this condition. This is going to return false, so line 5 never executes. Then it's going to evaluate this condition. This will return true, so line 11 executes. Then it will evaluate the final condition. Foo is equal to hello with a capital O. That is false, so line 17 will never execute. And I know that that's rather obvious, but I want to point out that this is inefficient code because we have to evaluate each of these conditions regardless of finding a true condition here. So as far as efficiency is concerned, once we find this condition, we shouldn't be performing this other condition because we've found a match. So instead of using if, and then if, we can use something called an if, followed by an else if, followed by yet another else if. So the idea is kind of the same as the if and the else, except that we are performing another comparison. So whenever this condition is evaluated, this is going to return false. So once again, line 5 will not execute. But then with this else if, this comparison is going to be evaluated. This is going to return true, so line 9 is going to execute. But since this returns true, there's no need to perform this else if comparison. So whenever we execute the code on line 9, this whole if, else if is going to exit, and then we execute whatever is on line 17. So we've made our code a little bit more efficient because now we're only comparing the values that we need to compare. So if we were to put this comparison with all lowercase letters at the top, then that one condition will be evaluated and then none of the other conditions will be. So just to show you, let's run this in our code in our browser. We're going to get the same results as we got before. But we can also add an else statement at the end of this so that if neither of these conditions return true, then we can say no match was found. So let's go ahead and change this to have a capital L. And if we run this within the browser again, we will see that no match was found because each of these if and then else if conditions were evaluated. All of them returned false. So then we finally went to this else block. So that's how we make decisions in our code. We use the if statement to test a condition. If that condition is true, then of course we execute the code within that if statement. If that condition is false, then we have the else statement to execute code. Or if we want to test another condition, if our first condition returns false, then we can use the else if statement to test another condition. So now let's look at logical operators. Before we do that, I'm going to add another variable called bar, give it a value of 5, and let's say that we need to execute some code based upon if foo is equal to hello and if bar is less than 6. Well, if we try to execute this code, we are actually going to get an error. So let's go to the browser, refresh. Nothing's happening. But if we look at the JavaScript console, we will see that we get an uncaught syntax error, unexpected identifier on line 4. So if we look at line 4, it's this bar identifier that it's talking about. We have a comparison, foo equals hello, and then we have another comparison, bar is less than 6. But this is an invalid syntax because there's something that should go in between these two comparisons. And this is where the logical operators come in. Logical operators work with Boolean values, and conditions evaluate to Boolean values. So the logical operators allow us to combine multiple smaller conditions into larger, more complex conditions. The first logical operator we'll look at is the logical and I'm going to type these out because this can get a little confusing. And if you're going to type the text version of the logical and operator, then you would want to do that in all uppercase. But in code, the logical and operator is 2 ampersands. It's not 1 ampersand, that's actually the bitwise and, which we're not going to get into bitwise operators at all. So the logical and is two ampersands, and it's a lot like the word and in the English language. So let's say, do you like cake and pie? Well, you have multiple answers to this question. If you like cake and you like pie, then the answer is yes. If you like cake but you don't like pie, then the answer is no. If you like pie but you don't like cake, then the answer is no. And then naturally, if you don't like cake and if you don't like pie, then the answer would be no as well. So, as far as the logical and operator, if we have true and true, then the result of this logical operation is true. If we have true and false, then the result is false. If false and true, then that is also false. And if false and false, then that is false as well. So if we want to use the logical and operator in this code, which we do because we want to check if foo is equal to hello, all lowercase, and bar is less than 6, then we would want the logical and operator. So whenever we run this code, we will get the value of true within our little alert box, and let's comment out this second alert window. Okay, so that's the logical and operator. The second logical operator is logical OR. Once again, all uppercase, and in code the operator is 2 pipes, and it is not one pipe. That is the bitwise OR, so you want to use the double pipe for the logical OR. The logical OR is like the word or in the English language. So do you like cake or pie? There are different answers, obviously, to this question. If you like cake and if you like pie, then the answer is yes. If you like cake but you don't like pie, the question is still yes because it's an or question. Do you like cake or pie? Yes. So if you like pie but you don't like cake, that once again is yes. But if you don't like pie or you don't like cake, then that is no. So it's a different result set than the logical and operator. So if we have true and true, then the result of the logical or operation is true. If we have true and false, then the result is true, because it's an or question. Once again, if one of the operands is true, then the logical or is true, and I'm saying logical and here. Why didn't you tell me? Okay, so let's do that. So if we have false or true, that is true, and then if we have false or false, then that is false. So if we change this logical and to logical or, as it is right now, this overall condition is going to return true because both of these smaller conditions return true. Even if we change one to be false, foo is not equal to hello. Well, that's obviously false because foo does equal hello, but we have this other condition that is still true. So if we were to run this within the browser, we would see the alert box. So in order to not see the alert box, we would have to make both of these conditions return false. So by changing the sign from less than to greater than, that is going to return false for that condition, which will mean that we will not see our alert window anymore. The last logical operator is logical not. And it's very simple. It just has an exclamation point. It's not 2, by the way, it's just 1 exclamation point. And unlike the logical and logical ors, you use the logical not on only one Boolean value. And what it does is it switches the value. So not true results in false, not false results in true. And you might think, well, how do we use that? Well, let's get rid of this second condition because we don't need it. And let's say that we want to reverse the result of this condition, because as it is right now, this is returning false. Foo does equal hello, but naturally we could just change the operator to the identity, but that doesn't help us with this particular demonstration. So we use the logical not operator before the Boolean value. So we want to stick it at the beginning of our condition, but we haven't quite done what we wanted to do. We are saying not foo is not equal to hello. That really doesn't make a whole lot of sense. Actually, it does, but we'll get to that in a moment. So instead, we want to surround the condition with parentheses, because just like the mathematical operations where we can change the precedence based upon parentheses, we can specify parentheses around a condition in order for that condition to be executed first. So now that foo is not equal to hello is executed first, this is going to return false. And then we use the logical not operator to reverse that false to true. So if we run this code, we will see our alert window once again. And why didn't we? Because I didn't save it. That's always good. So refresh, and there we have true. Logical AND and logical OR allow us to group multiple conditions into a larger condition so that we can compare multiple values together. And then the logical NOT allows us to switch the result of a condition or multiple conditions. There's just one more thing that I want to show you and then I'll let you go. I know we're running a little bit later than normal and I apologize, but this is very important. So far we've been talking about just pure true and false values, but JavaScript is a little unique in that it has something called truthy and falsy values. The idea is they are not true or false. They are actually values of other data types, but they are treated as true and false. So they're not true and false. They are truthy and falsy. So let's look at the truthy and falsy values of other data types, because it does come in handy to use other data types as inside of your conditions. So we'll first look at numbers. We'll use 0 as our condition, and we'll just alert a message. 0 is a falsy value, so if we try to run this, we aren't going to see our alert window. But if we change it from 0 to any other number, it doesn't matter what number it is, as long as it's not 0, we will see our alert window. So as far as numbers are concerned, 0 is falsy, and any other number is truthy. So strings. The empty string is a falsy value. But if we even add just a single character, then this string is now truthy. So if we refresh, we see our alert window. Arrays are truthy, as are objects. There we go. And we don't have the equivalent of falsy for those. Well, actually we do. We have talked about undefined before. In that whenever you declare a variable, but you don't give it a value, it's said to have a value of undefined. So if we were to use foo as our condition, we would not get anything whenever we refresh the page. And that's because foo is undefined. We can even use the undefined literal value, which I discourage people from using, and by the way, that's not working. I discourage people from using undefined because it's not protected. You can actually assign a value to undefined and change its value. So as it is right now, it's not very reliable. But in a future version of JavaScript, then undefined will be protected and you will not be able to change its value. There's one other value that is called null. This is a falsy value as well, and null is a null object. If you were going to use the type of operator on null, and let's go ahead and do that, alert type of null, we would see object because null is a null object, but it is a falsy value. So you could use the null literal value if you wanted, or you could assign it to a variable and then use that as the condition, and we don't get the alert box that says hi. So anyway, that is going to wrap us up for today. What did we talk about? We talked a lot. We talked about conditions and how we use conditions to make decisions in our code. And we also looked at how we can make decisions using the if else and else if statements. We also looked at truthy and falsy values as well. So tomorrow we are going to look at loops, which allow us to repeat code over and over again, and we do so based upon conditions. The next lesson is going to build upon what we talked about today. So have a great one. I will see you next time.